Hey, this is Calculus Explained, and today we are going to be covering an introduction to limits. So, I'll start off by explaining a bit about what calculus is. Calculus is built on the idea of motion and change. Limits let us measure what happens at the exact moment something is changing. So before we can even talk about derivatives or integrals, we first need to understand limits. Limits provide the backbone to both derivatives and integrals. We can first start off by looking at a simple graph. We have a function, but we'll say that there's a hole at x equals 3 and y equals 2. Now the notation for limits is written like this. Now in our scenario here, we write it like this. This is read as the limit of f of x as x approaches 3 is equal to 2. Now what this is saying is as we get closer and closer to x equals 3, f of x gets closer and closer to 2. So even if we don't know what the function equals at a point, even if there is ruled as continuity like we have here, a limit helps us describe the behavior nearby. Now let's look at one-sided limits. We'll say that the limit as x approaches a from above of f of x, and the limit as x approaches a from behind of f of x. We need these to be equal for a limit to exist. If these are not equal, then a limit doesn't exist. Here we can see from the positive side, we get the same limit as from the negative side. What these one-sided limits are saying, this plus and this minus, is we only look at the behavior as f of x gets closer and closer to a value from one side. For the plus, we see this plus right here. From the right-hand side, it gets closer and closer to 2. Negative side, it also gets closer and closer to 2. That is what a one-sided limit is. So, what about when a limit does not exist? This is when these do not agree. When the one-sided limits do not agree, a limit will not exist. There are 3 different examples of this. Draw 3 different graphs. The first one is called a jump. That's when a function looks like this. It suddenly goes from one point straight to another. We can almost think about it like 2 different parts of a function. It just suddenly jumps from this value to this one. Here we can see that the limit as x approaches, we'll say that this right here is x equals 2, this is y equals 1, this is y equals negative 3. The limit as x approaches 2 from the positive side of f of x is equal to 1. From the negative side, it's equal to negative 3. Now, since these are not equal, we can say that limit does not exist, or limit DNE is how we say this. So this is a jump. The next one is when you have a vertical asymptote. So we'll say that we have a function here with a vertical asymptote at x equals 1. So as from the positive side, as x approaches 1, we see that you get closer and closer to negative infinity. From the negative side, you see that f of x gets closer and closer to positive infinity. This is the next scenario of when a limit does not exist. Finally, we'll look at a scenario called oscillation. We'll set this the graph of sine of 1 over x. You can see that as x gets closer and closer to 0, the function rapidly oscillates. So there's no set value for what f of x is approaching. This means that the limit as x approaches 0 does not exist. So this is oscillation, and this is vertical asymptote. So those are the three scenarios when a limit will not exist. Now let's look at a few practice problems. Pause the video, go through these on your own, come back, and we'll go through them together. Welcome back. We'll go through these together now. So we can first factor this one. We'll see that it's a difference of squares. This is an algebraic technique that helps us to evaluate limits. When you can factor like this and eliminate, then you can use direct substitution and evaluate the limit. Now this scenario, we can see graphically. This is the function absolute value of x over x. From the positive side, it's not going to be equal to the negative side. You can immediately see that. So from the positive side, you see that this value is always going to be equal 1. From the negative side, it will always equal to negative 1. These do not equal to each other, so the limit does not exist. Last scenario. The limit of f of x as x approaches negative 2 based on this graph. You can see from the graph, this is removable discontinuity at the point negative 2, 3. So that means that this limit is going to be equal to 3. And that is the solution to these problems. If you had trouble with any of these, make sure that you go back through the video and relearn any concepts that might be challenging to you. I hope this video was helpful. So now you know about limits and what limits mean. Next time, we'll learn how to compute limits using algebraic techniques such as this problem right here. And this provides the fundamental basis to all problems you'll see in calculus. Whether it be an integral or a derivative, you are going to need to understand what limits are. So that concludes this video. Thank you for watching, and I'll see you next time.